So I'm recording the AP study group on Tuesday, May 18th. Here we're looking at the AP Calculus AP exam that was given on May 4th of 2021. So it just came out about a week or 2 weeks ago. Actually, this exam was given exactly 2 weeks ago. So it was given, probably released maybe about 10 days ago. So this is an FTC style problem. How do I know that? Because usually when the College Board tells you that some function equals the integral of another function, they're checking to make sure that you know this, that G prime equals F, and that G double prime equals F prime. You kind of want to establish that right away. And if you kind of put it anywhere near the top, the grader will know that you mean that for all parts. So that's, they look at whatever work you got on the page. And usually have like a little booklet where you kind of write your answers in. They do say F is continuous, and look at the graph. From -4 to 6, obviously. 4 line segments, obviously. Okay, so let's do part A. On what open intervals is the graph of G concave up? Remember, we want your concave up, G double prime must be positive, or F prime must be positive. Okay, take a moment to think that through. Try to identify what F prime would be here, what F prime would be here, what F prime would be here, and what F prime would be there. And they do say open intervals, so don't worry about, oh, do I need to do brackets or parentheses? The College Board over the last few years have kind of decided, let's just avoid the ambiguity, just give us open intervals. So don't be concerned about that. Just give me the numbers. So take a moment to think about it, and then of course you have to give a reason. And I'll show you how you actually have to write it. Okay, so hopefully you realize that F prime is positive here, negative here, positive there. Concave up means G double prime has to be positive or F prime is positive. So it should be obvious that we're looking over here and we're looking over here. So your answer is going to be from -4 to -2. Union from 2 to 6. Because G double prime or F prime is positive on those intervals. That would be your justification. Do you have to say both G prime or F prime? No, you could just say one of them, but you do need to establish this.
If you just say like G double prime equals F prime is positive, or like,
sure.
Is that the same thing?
Yeah, sure. Yep. Yeah, that actually would be a way to consolidate what I have up top and then down below. So my guess is it's probably worth it. We don't know the rubric because they haven't graded this exam yet. So we won't know until much later, maybe not until probably sometime midsummer. But my guess is 1 point for the intervals and 1 point for the reasoning. So it's probably worth 2 points is my guess. So if you give the intervals, great, you get a point. If you don't give a good reason or don't say a reason, then you're not getting all the points that are available. So make sure you state the reason correctly. Okay, let's look at, let me minimize this because we need to be able to keep seeing the graph of the parts. Oh, good, we can see all the questions, perfect. Okay, part B, let P be the following function, find P prime of 3. So what you're gonna have to do is you're gonna have to do the product rule, okay? You have to do the product rule. In case you forgot, product rule is this, P prime of X will be G prime of X, but then times F of X, and then reverse course, G of X times F prime of X, okay? Then plug 3 in, and remember G prime equals F, and G does equal an integral. So have fun with this one. Okay, I'll give you a couple minutes. You get 15 minutes per question. I'd say part A, you should do in a minute or two. Part B, don't rush it. Take about 3 or 4 minutes. And my guess is they'll probably give you a point for doing the step I just did with the product rule. And then maybe a point for substituting things correctly, and then another point for the final. So I'm guessing this is probably worth 3 points. So go and work through this one. I'll give you guys about 3 or 4 minutes, and then we'll talk about the answers. Okay, let's talk. So G prime of 3 f of 3, g of 3, f prime of 3. G prime of 3 is simply going to be f of 3, right? So you have f of 3 twice being multiplied together. And that's super easy, right? F of 3, just look at the graph, is negative 3. So you're going to have negative 3 times negative 3. I'm pretty sure I'm looking at that correctly. F of 3, my eyes are not deceiving me. Yeah. So that's going to be 9. G of 3 is actually going to be an integral. So that's the part where you have a little bit of fun. So you're going from 0 to 3. Now, fortunately, from 0 to 1 and 1 to 2, those will cancel out because those are triangles of the same dimensions. So you have this little trapezoid here, or you can break up the rectangle in a small little right triangle. And it's a negative area because it's below the x-axis. So the rectangles from 1 to 3 plus half. Actually, count the squares. Each square is an area of 1. Excuse me. So that's going to be 3.5. So actually, let me just put 3.5. I know that now. Times f prime of 3, which is just a slope to the slope at that portion, which is slope of 1. So you should get 12.5 for that one. I think I did that right. Let me just double check. G prime of 3 is f of 3, f of 3 is, yep. Oh, oops. This is a negative area. I knew I did this wrong. Because it's another student. Okay, my apologies. Our G of 3 is actually negative 3.5. My apologies. And of course, f prime of 3 is the positive slope at that portion is 1. My bad. So 5.5. That's what we get, 5.5. Okay. So that's, now I know that's the correct answer. Okay. So now let's move on to part C. Part C is going to be L'Hopital's rule. How do I know that? If I plug in G of 2, so you guys show that. They're going to give you a point. And by the way, going back to part B again, doing the product rule is worth 1 point. Substituting those values, my guess is, or like at least find the integral and the derivatives are probably worth another point. And again, the final answer is worth the final point. So here, I'm guessing they'll give you a point for testing 2. And G of 2, remember, G of 2 is the integral from 0 to 2, which of course that cancels out. So because it's indeterminate, L'Hopital's rule will apply. This is the way they sneak in L'Hopital's rule. Okay, that's the way it's snuck in. So let's do it. Do L'Hopital's rule. You gotta do G prime of x over 2x minus 2. And you still have to write the limit, by the way. So you'll lose that point. So my guess is they'll give you a point for doing this part. And a point for doing this. And then probably 1 point, excuse me, for getting the answer, is my guess. The more I think about it, there are really not that many points left. Perhaps maybe part B is worth 2 points then, or maybe part C, I don't know. We'll see how they divvy up the points. But then what you need to do is now plug in 2. So G prime of 2 over 2 times 2 minus 2. Well, G prime of 2 is f of 2, so G prime does equal f. The bottom's going to be 2. F of 2 straight up is negative 4. Negative 4 over 2, you get negative 2. There you go. Yeah. So there's L'Hopital's rule in all its glory. So any questions about part C? All right. Lastly, let's look at part D, and then we'll do another problem. So find the average rate of change, and then does the mean value theorem guarantee that you'll find some value C, with C being x value between negative 4 and 2, such that G prime equals average rate of change? Okay, so go ahead and find the average rate of change, which is going to be G of 2 minus G of negative 4. So you're going to have to do some more integral work over 2 minus negative 4 to do that. and then make your statement about this. So again, I'll give you guys maybe a couple minutes for that. My guess is 1 point for the average rate of change and 1 point for making your statement. So I'm guessing D is probably worth 2 points. So again, I'll give you guys a couple minutes to handle that. Okay, G of 2 we already know 0. G of -4 is going to take a little bit of work. Remember, we're integrating from 0 to -4. So you could chop this up. Gosh, hold on. What is the best way to chop this one up here? Actually, there we go. That's the best way to chop it up. So that's 8. That's 2 times 6. Half of that, that's 6. That's 2 and 2, so that's 2. But it's all negative because you're going backwards. So that should be -16. And of course, the bottom part is 6. But 0 minus -16 is 16. So you have 16 over 6, which of course is 8/3. So is it possible that G prime will equal the average rate of change? Well, remember G prime is F, right? We know this. For mean value theorem to apply, remember, we're doing this for G. We need G to be continuous and differentiable on an interval. It's actually an open interval for the differentiability, but the continuity, a closed interval. Well, here's the thing. F is continuous on that interval. We know that. Look at the graph, right? If F is continuous, then G prime exists everywhere, right? Because G prime is equals everywhere on that interval. If G prime is differentiable, or sorry, G prime exists everywhere, then G is differentiable. If you're differentiable, you're definitely continuous, because we talked about it a while ago. So the answer is yes. It does guarantee it. No problem. I'm going to still do another problem. So, okay. So hopefully that gives you, and you know, this is a very typical problem. If you look at all the past AP exams I've given you guys, They ask this every year, and I felt this was a pretty straightforward one. I thought this was a totally fair problem.
I kind of forget, but like if we were to be solving like a mean value theorem problem, how would you like go about like I remember like setting the average rate of
just
change
take the average rate of change,
to,
which we did, and take the derivative and set them equal to each other. So if you're given an actual function, like let's say f of x equals x cubed plus 4x, right? And you want to do this from like 0 to 2. Then you do f of 2 minus f of 0 over 2 minus 0, which we did in the problem anyway. Here, and then you take the derivative, which we can't really do because we don't know what the function is. But you take the derivative, and then you work out this number and set equal to 3x squared plus 4.
Okay, that makes sense. Thank you.
Yeah, that will probably be something you'll see probably as a multiple choice question, because they try to keep those more straightforward ones. They get a little more abstract as they do here, but it's not hard. You just have to just know the concept, right? That a g prime equals f is defined, f is continuous everywhere, so g prime is defined everywhere. That means that g is differentiable, therefore it's continuous, and VT applies. Okay, so next up we have, I'm not sure what you would really call this concept. It's kind of a hodgepodge, I think, of different things, but a little bit of implicit differentiation, I would say, for sure. So they want you to prove that this is true. So you'll need to do is you need to do implicit differentiation. I'll get you guys kickstarted here. I'll let you guys kind of carry away, but you'll need to take the derivative of both sides with respect to x, because they ask you to, right? So you have 2y squared minus 6. And then doing d dx to the other side, right? Of y times sine x. So remember implicit differentiation. So what you got to do is take the derivative of 2y squared, which I know is 4y, but you got to say dy over dx. Derivative of negative 6 is just 0, straight up. Then you got to do a product rule here. So it's the second time they're asking to do product rules that we've seen so far. So you got to do a derivative of y, which is 1, but times dy over dx, and leave it multiplied to sine x, plus y times derivative of sine, which is I know is cosine x. Now your job is to isolate dy over dx, which is not hard to do. I can move this portion to the left side, factor out dy over dx, and I should get this answer. If you do it correctly, move the part I have circled in green from the right side to the left side, factor out dy over dx, you get 4y minus sine x, then divide both sides by that expression, you should be able to prove it. My guess is they'll probably give you 2 points for this one, 1 point for doing derivative of both sides, and then 1 point for actually getting, the process. So hopefully that makes sense. Any questions about that one? Nope. Part B should be pretty straightforward also. Equation of lines are this. Okay. Write the equation for the tangent line to the curve at that point. Okay, well, the average derivative. So my guess is they'll probably give me maybe 2 points. 1 point for kind of the overall form, like a y minus root 3, x minus 0. For the slope, you just got to plug in the points you're given. So root 3 for y, cos 0, over 4 root 3 minus sine 0. Well, sine 0 is 0, but cosine 0 is 1. So you have root 3 over 4 root 3, which is 1/4. So there you go. So again, pretty simple. Okay, now I'm going to have you guys think about C or D. For C, find the coordinates where the tangent line to the curve is horizontal. So you want dy over dx to equal 0 if you want a horizontal tangent. And you have to keep it in that interval from 0 to pi. So essentially, you need to set the numerator equal to 0. And you're told that y is positive. Okay. So let you think about that one. And my guess is they'll give you a point for establishing that dy over dx equals 0. That's probably worth 1 point is my guess for making that establishment. And it made 1 point for actually getting the answer. The next one I think is going to be probably worth 3 points because it's a little more involved. What you'll need to do is you need to do a sign chart. Actually, yeah, do a sign chart for dy over dx. Or you can kind of look at it through inspection. You can do a second derivative, but that's going to be really messy. You could. We'll see how that looks. But go ahead and figure out C, figure out D. We'll give you guys maybe about 4 or 5 minutes for that. We'll discuss, and then we'll do one more problem after that. What are you guys getting for X for part C?
I got pi over 2, but
Yep.
I'm not, yeah.
Yeah, so you should know your unit circle, right? Good. Yeah, y is positive, so that y is not going to be 0 there. And again, in order to get a horizontal tangent line, you have to have your dy over dx equals 0, because dy over dx equals a fraction. The numerator must be 0. The numerator is y cos x, but y is positive, therefore cos x has to be 0. Knowing your unit circle only has to pi over 2. Good. Okay. Yeah, don't take too long with that. The other part you have to kind of think about a little more carefully. What's going on at pi over 2? Let me go ahead and clear my screen here because I'll need some space. So you could potentially say, well, here's a sign chart, pi over 2. Technically, you should also look at what makes the bottom 0, because those are critical points. That's at 0 and pi, but I mean, we're really just interested at pi over 2. So yeah, if you kind of consider what's going on in the, because this is Q1, by the way. That's Q2. So if you think about Q1, I know sine and cosine are both positive there, right? And you're told that y is positive anyway, because yeah, we are between Q1 and Q2, where y is positive. So if we're kind of careful about it, you can kind of say, well, if y is always positive, and cosine is definitely positive in the first quadrant, so the numerator is going to be positive in Q1. Here, you have 4y minus sine x. Now, it is a little tricky, but most sine can ever be is 1. That's the highest sine can ever be. And sine takes on a value of 1 when you get close to the y-axis. And of course, y is getting bigger itself too. So I highly doubt that we're going to see this to be the bottom going to be negative. Even if it is, it's probably going to be like way over here somewhere. So I'm pretty sure our derivative is going to be positive before I get to pi over 2. After pi over 2, cosine now becomes negative, right? Y is still positive, and sine is a positive value still. And for y, again, y is still high. So my guess is now you're negative. So you're going to have a relative maximum. And you would just show because f prime changes sign, or changes from positive to negative. At x equals pi over 2. That would be your justification. Now, if you so desire doing a second derivative, kind of hesitant to do that, but okay, if you do that, you got to do a quotient rule with a product rule. Yikes. So you have 1 times dy over dx. You know, I'm not going to do it. It's just going to take too long. Just trust me. The sign chart. Let's move on to number 6. I will have to end the call around 9:30 because, as you can tell, I do need to actually get ready and to teach you guys. So I have to get to campus. So we'll do one more problem, and then tomorrow I'll do 1, 2, and 3. And then on Friday I'm going to kind of do kind of an overall type of just review of everything, because I know some people are doing this on May 24th. So yeah, let's take a look at this guy here. Okay, so they give you a differential equation, and they tell you that the initial condition, we have 0 hours, 0 milligrams. Fine. First, they want you to draw how the curve would look past 0, 0. So really what you want to do is you want to kind of follow the contours of the graph. If you so desire, you could like plug in, like say, well, what if y is like 1? And by the way, you see how you have horizontal tangents here? That's definitely happened at y equals 12. So my guess is each of these tick marks are each worth 1 unit, or are going up in that fashion, you know? So yeah, excuse me. So you just kind of want to simply follow the contours of the graph. Like for example, if I plug 6 in for y, my slope's supposed to be 2. I'm not sure what x coordinate would be, but probably just be kind of like this. And just make sure you show it flattening out. I guess they probably just give you 2 points for this one at most. 1 point for passing 0, 0, 1 point for kind of showing a horizontal tangent as you get closer to y equals 12. So don't overcomplicate that one. And just do your best to follow the contours of the slope fields. That's all. For B, interpret what that means. Now, t is approaching infinity, and they tell you the limit is 12. So we don't know what a of t is exactly, but what you'd want to say is that as t approaches infinity, a of t, or a prime of t, actually, you want to say that. Approaches 0. Because, well, actually, a prime.
Okay, is 12 like an upper limit of the
It's a horizontal asymptote.
problem? If it'll never equal 12, and it'll never
right,
be above.
exactly. Yeah, I mean, you could say this. Actually, yeah, really, we should be saying it as t approaches infinity, a of t gets closer to 12 because it's horizontal asymptote. And how do I know it's horizontal asymptote? Because a prime is approaching 0 as t gets closer to infinity. Or a prime does equal 0, actually. At y equals 12, which would indicate you have a horizontal asymptote. So I guess the way to properly write this, because I'm kind of all over the map here with you guys right now, I guess what you could say is that as y equals 12 is a horizontal asymptote for A of t, since dy limit of that, I think that's really what they're looking for. You got to make a mention of that, of it being a horizontal asymptote, and how you know that because of the the derivative being 0, because then that means they have a horizontal, it has a horizontal line behavior, the end behavior, right? So you have to make that kind of statement. My guess is that's probably worth a point, maybe 2 at most, but I'd say probably just a point. Okay, C is a big one. And I've not lied to you guys. And actually D as well. D is a big one too. My guess is, yeah, B probably worth 1 point. A maybe even with just 1 point or 2 points. C is definitely worth at least 4, maybe 5. D does look kind of long, but it's really not that bad. It's just more you have to kind of understand what's going on. But go and take a look at C first. So you have to solve the differential equation. We've done this many times. You'll divide both sides by 12 minus y. And you have 1/3 dt. So I've already done the first step for you guys, the separation. Then you got to integrate, solve for C's initial condition, and then isolate y. I'll give you guys about 4 or 5 minutes to do that one. Okay, so if we get natural log of 12 minus y equals 1/3 t plus c. Plug in 0 for both y and x, you get natural log of 12 equals c. There you go. So now you have natural log of that 12 minus y equals 1/3 t plus natural log of 12. So you're getting a point for the separation. You're getting a point for doing the antiderivative. You're getting another point for solving for c. Don't spend too much time on trying to solve for y if you're getting kind of stuck. It's also kind of why they put it near the end, because people might take a long time doing it. So, and actually, I've heard that directly from the people who written this exam and who grade for the College Board. But 12 minus y will equal e to all that junk, which is actually broken up like this: e to the 1/3 t times e to the well, natural log of 12. Yikes! Sorry about that. Natural log of 12, which of course is just 12. So you get 12 e 1/3 t. And then 12 minus y will equal plus or minus that. You get rid of the opposite value. If you plug your initial condition, 0 for y and 0 for t, you get 12 equals 12, so you're going to drop the plus or minus. It's not going to be negative. Do be careful about that. So then we move things around. We get y on the right side. You get 12 minus 12 e 1/3 t. And there you go. That's the final answer. It's very straightforward. Questions about that one? All right, last one. Let's do part D. So part D is saying the different procedures used to administer the medication to a second patient. The amount, blah, 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 satisfies the following differential equation. At t equals 1, there are 2.5 milligram medication in the second patient. Is there any change in the amount of medication in the second patient, increasing, decreasing at t equals 1? Well, really, you're just plugging in this into dy over dt. So you plug in 2.5 for y and 1 for t. It's 3 minus 2.5 over 3, which of course is positive number, right? Because it's a positive number, oh, but is a rate of change increasing? So your rate of change is positive, okay. We actually needed the second derivative. So actually plug with 1 and 2.5 was actually kind of, well, actually it was good. We should do that regardless, because we do need to know what dy or dt is. More specifically, actually I could probably call it 9 over 3, which is 6.5 over 3. Okay. You still need to do the second derivative because you have to see what is concave up or concave down to see if the rate is actually increasing or decreasing. So if I do the second derivative, I get 0. This is d2y over dt squared. You get 0 minus, and then you got to do a product rule. So it's going to be y prime times t plus 2 minus y times 1, because derivative t plus 2 is 1, over t plus 2 squared. So be careful here. 0 minus y prime I know is positive. So 6.5 over 3. Plug in 1 for t, you get 3. So those cancels, you get 6.5. Y is 2.5, so you get 4 up top. And down below, 1 plus 2 squared is 9. So you get negative 4/9. I'm concave down. So the rate is actually decreasing. So that's what you have to do. So remember, it's asking how the rate is changing, how the derivative is changing, so you have to do a second derivative. But you still have to find the value of the derivative anyway when you're finding the value of the second derivative. And overall, it's negative, concave down, so it's decreasing. So that's what you do for that one. My guess is find the getting the value of the derivative is probably worth 1 point. Doing the whole quotient rule bit is probably worth another point, and then probably a point for your answer. So I'm guessing part A and B are probably worth 1 point each. Part C is probably worth 4 points, and part D is probably worth 3 points. That thing's how they would divide those points up. Okay, so hopefully that kind of helps to get a better feel for half that AP exam. I was just trying 1, 2, 3, 4. So for number 1, number 2 is linear motion. So Ella, that's something that we did recently. So you should be pretty comfortable now doing that. We'll probably talk about that during class anyway today. Number 1's kind of seems like a hodgepodge of different things, but we've done Riemann sums, we've done determine whether over under estimates, we've done average value. 3 is looking at volume, like of revolution, which I have not done with my D period students yet, and area between two regions, which I'm actually doing today. So yeah, I mean, you guys have seen all this stuff. So conceptually, I felt this was a totally fair test. I do think the math, especially for number 3, and I think even parts of 1 and 2 were a little intense. I felt 4 was totally fine. I felt 5 was fine as well. I don't think there was anything too crazy there. I do think 6D was maybe a little confusing, but for overall, I felt this was still a pretty fair test. So I'll stop the recording.